cable 20 feet long and weighing 6 pounds per foot is hanging off the side of a 30-foot tall building. At the bottom of the cable is a bucket of rocks weighing 100 pounds. How much work is required to pull 10 feet of the cable to the top of the building? Okay, I drew this little picture here. There's a lot of numbers and stuff on it, but I'll explain all of them later. Alright. Okay, so I drew this little picture here to illustrate the problem. So, thankfully, first we know work is the integral of force in respect to distance. And thankfully, the problem gives us that the bucket of rocks weighs 100 pounds, weighing 100 pounds. So that means our force is already told to us because it's not the mass, it's the weight. Because weight is equal to force, and then mass is equal to m. So that's good. But the problem here is that our cable is reducing in weight for every centimeter or foot that we pull up to the top. So we can create an expression for that. So to find the weight, we take our 6 pounds per foot and we multiply it by some x amount of feet. So at 20 feet, then it'll be 120 pounds. At 10 feet, it'll be 60 pounds. So what we can do is we can make an expression, and if we say, now, having just x as the amount of rope out doesn't really help us so much. But because we're trying to pull it up, so we're reducing the amount of rope. So if we had 20, which is our full length, minus x, then this is an expression we can use to actually find the weight at each, depending on how much is pulled up. Because at whenever we have the full length out, so that means x is 0, then we have 120. Whenever half of it is pulled up at 10, then we have x is 60. So we use this formula, which is going to be our other weight. So what we can do, and this is a weight because it's in pounds, so we can have our integral of 100 bucket of rocks, because that's always going to be there, plus this expression for the weight of the cable, 20 minus x, and then that's going to be for every little sliver, and then we're pulling it from 0 all the way up to 10. So I might have explained that a little bit incoherently, or might have not made sense, but basically weight of rocks, weight of the cable, and then we're raising it up from 0 to 10. So like a 20, 10. So now let's solve this integral. 100 plus 120 minus 6x. We add these, then we get 220 minus 6x dx, integral from 0 to 10. And so most of this, the problem with these questions is just creating the integral. Often the actual integration is never hard. So we found our antiderivatives, then we go from 0 to 10, and so 10 is going to be 220 minus, is going to be 10 squared is going to be 600, so it's going to be 10 squared is 100, multiplied by 6, 600, divided by 2, 300, and then that will be 1900. And then we've got to remember our units, feet, pounds. And there we go. Because we're taking a force, which is in pounds, and multiplied by x, which is our feet, and there you go. That's your answer, which will be B. Okay, compute tangent cubed of x multiplied by secant cubed of x dx. Now, we're not using integration by parts. Do not think about that, because that will make your life a lot worse. We just use simple u sub for this one. So u sub with a little bit of trigonomic manipulation. So let's say u is equal to secant of x, because we know that the derivative of secant is secant of x tangent of x dx. So what we know is we can take out a tangent, take out a secant, and take both of those out of this tangent. squared multiplied by secant squared dx. So now we have our two things, and we can sub in. So now we have tangent squared multiplied by u squared du. But we still have this tangent squared, so what are we going to do about that? Well, here's another identity. So we know sine squared plus cosine squared is equal to 1, of course. Now, if we divide all of this by cosine squared, what do we get? We get tangent squared plus 1 is equal to secant squared. So, and then if we move over our tangent, or move over our 1, we get secant squared minus 1. So we can plug that in. Get secant squared minus 1 multiplied by u squared du, and we know our secant is u, so we have u squared minus 1 multiplied by u squared du. And there you go. So simple. We distribute u to the fourth minus u squared du, and then we just integrate and plug everything back in. So we go u to the fifth over 5 minus u to the third over 3, plug in our secants, and what do we get? We get 1 over 5 secant to the fifth of x minus 1 over 3 secant of to the third to x plus c. There you go. That's your answer. And that'll be A. The region bounded by the curves y equals x squared and y equals 1 is rotated about the line y equals 1. Find the volume of the resulting solid. I feel like, isn't it supposed to be rotated? They are rotated, but whatever. I'm teaching math, not English. So let's start off with a little graph here. So we see that our graph is going to look like this. This is our x squared. And then our y equals 1 is going to be like here. And so now we're trying to find the area right around here. So there's some methods we could use, but one way to think about this problem is, if you think about it, this is essentially the same as rotating x squared minus 1 around the x-axis, because it's the same thing, we're just raising it up, we're raising it down and then it's rotating the same area around the x-axis. So with that, it would be the same as a circle pi r squared. So it would be pi multiplied by x squared minus 1 squared dx. And so our limits will stay the same because we're just shifting the graph down 1, because it's going to still hit the x-axis at the same points. So to better illustrate what I'm talking about, maybe, so this is the same. These two areas are the same. This is y equals x squared minus 1, and so it would be the same. So, and then our bounds are going to be negative 1, 1, because if we were to set x squared equal to 1, then our x would equal to plus or minus the square root of 1, which is just 1. So it could just be that. And so now we just solve, and there you go. So this will be x to the fourth minus 2x squared, I think, and then plus 1. Negative 1, 1, pi. And then there you go. Then you get x to the fifth over 5. Then you get minus 2x cubed over 3 plus x. By the way, from negative 1 to 1. And so what do we get? We get 1/5 minus 2/3 plus 1. So I have that minus, so it'd be negative 1 over 5 plus 2 over 3 minus 1. And so now, if we distribute our negatives, then we get 1 over 5 minus 2 over 3 plus 1 plus 1 over 5 minus 2 over 3 plus 1. And then let's get rid of this stuff really quick. Move that over. And then we get 2 over 5 minus 4 over 3 plus 2. And so let's combine these two fractions here. And then we get, what is that? 6 over 15 minus 20 over 15 plus 2. That becomes negative 14 over 15 plus 2. And that becomes negative 14 over 15 plus 30 over 15. And then that becomes, I know there's a lot of arrows going on. Then that becomes 16 over 15 pi. And then there you go. That's your answer. So you just have to imagine just similarities between graphs and realizing you don't need to use like a whole washer method or whatever for just a simple problem about rotating about an axis. There you go. Compute the integral from 1 to e of x squared multiplied by ln of x dx. So, seems like we're going to use integration by parts once again, but that's no problem, because integration by parts with these functions are actually pretty easy. I'll show you. So, integral from 1 to e x squared ln of x dx. So, I'm going to use the traditional method just so it's more obvious and better habits are built. So if you have u is equal to ln of x, then our u prime is actually equal to 1 over x. Then our v will be something that our v prime will go to x squared. So what do you derive to get x squared? Of course, x cubed over 3, because that's just reverse power rule. So now let's plug in everything in. So we have ln of x multiplied by x cubed over 3 minus this integral from 1 over e. By the way, all of these terms are going to be evaluated from 1 to e, so always remember that. And then it's going to be x cubed over 3 multiplied by 1 over x. And then we can cancel out these x's, and then that becomes get rid of that, that becomes a 2. Then we get x squared over 3. And there you go, that's it. You can solve that integral easily. So we can take out the 1/3, and then we get x cubed over 3, evaluate that from 1 to e, and we also got to evaluate this other stuff, ln of x times x cubed over 3 from 1 to e. So now let the simplification begin. So let's start off with this ugly stuff over here. So we have ln of e multiplied by e cubed over 3. This is going to be subtracted from ln of 1 multiplied by 1 over 3. So ln of e, since these are, I forgot the word is, but they're opposites, so this will be 1, going to value to 1, so then we get e cubed over 3. And then ln of 1 is going to be 0, because any base to the 0th exponent is going to equal 1. So this will actually be 0. So then this is our first term is equal to 0, or this is equal to e cubed over 3, because it's going to value to 0. And now we evaluate this one right here, and we get e cubed over 3 minus 1 over 3. And what would that be? Oh, it's the same base. So we get e cubed minus 1 over 3 multiplied by 3. So then it's going to be e cubed minus 1 over 9. So how do we simplify this? Well, we can do by that. So we have E3E9 minus E cubed minus 1, well, all of that over 9. And this expression here becomes 2e cubed over 9 minus 1 over 9. So there you go, that is A. And finally, we have our final problem of the first section, the multiple choice. So let's start. So we have the definite integral from 0 to pi over 4 secant to the fourth dx. So let's write that. Pi over 4 secant to the fourth of x dx. So this is similar to a problem we've seen before, where we can actually take secant and change it into an identity. So we know that tangent squared plus 1 is equal to secant squared. So we can take out a secant squared and then multiply this by tangent squared plus 1 dx, definite integral from there to there. And so now we can have our u be tangent squared, just tangent, tangent of x, then our du is going to be equal to secant squared of x dx. And so, how nice. So now we have 0 pi over 4, and then we have u squared plus 1 du. And then we get u cubed over 3 plus u. And so these bounds are actually wrong once again. I always write them, but I know I need to stop. And so we can actually evaluate these from different bounds. So what is the tangent of pi over 4? Well, if we think back to our unit circle, pi over 4, this is if pi over 2 is here, pi over 4 is here, and so the slope of this line right here is going to be 1. This is going to be a value from 1. What's the tangent of 0? We slope with this line right here, which is 0. So then we get 1 third plus 1 minus 0 plus 0, which is 0. And so then we get 4 over 3. And that is our answer. So it seems like a complicated integral, but it's actually very simple if you just remember your identity. And so yeah, so that is the last problem in the Common Exam 1 for Math 152. And I hope this video has helped you out, and if you have any questions, ask them in the comments. If I didn't explain something well, please tell me. Feedback is greatly appreciated. This is my first time doing any of these. So yeah, so just give me your feedback, and maybe I'll probably make another one doing the section 2 of Work It Out. And yeah, so I'll see you later.